Good morning, everyone. We are going to get started on Module 3, Lesson 3. And the objective for this lesson is to multiply and divide with familiar facts using a letter to represent the unknown. So let's go ahead and get started. Okay, to warm up our brains first this morning, we are going to review something we talked about all the way back in Module 1. And that is the idea of related multiplication and division facts. Okay, so the first one we're going to do, so go ahead and follow along with me either on your whiteboard or on a piece of paper. Okay, we're going to write 5 times 3. Okay, so we know if we do a skip count by 5s 3 times, I would do 5, 10, 15. So 5 times 3 is 15. So for the related division sentence, we would use the same fact family, meaning we would use 5, 3, and 15 again, but they'd be in a different order. Now in a division sentence, we have to remember that the biggest number always comes first. So in this fact family, the 15 is the biggest number. So the related division sentence for 5 times 3 equals 15 would be 15 divided by 3 equals 5. Or it could also be 15 divided by 5 equals 3. Okay, so it's important for these problems to remember that commutative property as well. Okay, so let's do one more. Let's do this problem down here. Blank times 2 equals 10. What multiplied by 2 equals 10? If you need help, you can do your skip count by 2s until you get to 10. 2, 4, 6, 8, 10. Okay, I skip count by 2s 5 times, so that must mean 5 times 2 equals 10. Okay, so the unknown factor for that problem was 5. Okay, now using our fact family, which is 5, 2, and 10, look at the division sentence. 10 divided by 2 equals blank. Well, which number from our fact family is missing? 5. So those two sentences are related because they use the same fact family. Okay, now let's look at the one at the bottom. 20 equals blank times 10. Okay, so let's write a skip count for 10. Let's see how many times we have to do it before we get to 20. 10, 20. That one was easy. We only had to skip count twice. So then our problem would be, our unknown factor would be 2. So 20 equals 2 times 10. Yet let's use that fact family to solve 20 divided by 10 equals blank. Well, we're missing 2 in our fact family, so 20 divided by 10 must equal 2. Okay, so that's going to be really important for today's lesson, using that fact families in order to figure out the related multiplication and division sentences. Good job. Go ahead and erase your whiteboards. Okay, so now we're going to go ahead and get started with the lesson. So go ahead and look at this array. It's like an array, but it's a rectangle. So how many groups of 9 are in this array? Okay, let's find out by counting by 5s. Okay, so we have 5 in each column. So if I were to skip count by 5s, I would count up here. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45. Okay, so there's 45 squares total. Okay, so first we started counting by 5, so we counted the columns. Okay, remember a column goes up and down. Now let's count the rows. So this way we'd be counting by 9s, but we know we'd still need to end up at 45. So I know we're probably more familiar with our 5s, but now let's practice our 9s. Ready? We're going to write them over here next to the rows. We have 9, 18, 27, 36, 45. Okay, so either way we counted, we end up with 45. We either skip counted by 5s or skip counted by 9s, not 45s. Goodness. Skip counted by 9s and 5s to get 45. So the two multiplication sentences for this array would be 5 times 3 equals 45, or 9 times 5 equals 45. Okay, let's add another layer to this problem. Okay, let's see. How many groups of 9 are there now? Okay, so if I just rewrite these real quick from our last problem. Okay, they added one more row of 9. So would we need to draw out our 9 skip count all over again? No, all we would need to do is add 45 plus 9. Because we're just adding another row of 9 to the array. And if I did 45 plus 9, I would get 54. Okay, so how could I use a multiplication sentence to represent this problem? Would it still be 9 times 5? No, it would be 9 times 6. Okay, but we're going to add the two problems together. So originally we did 9 times 5, which we said was 45. Then we added another row of 9, which would be 1 times 9. And we got 9 as our answer. And then we did 45 plus 9, which was 54. So 6 times 9 equals 54. Okay, so that's going back over that distributive property. Okay, when you break apart an array and then add more to it. Okay, so very good job with that. Okay, we're going to go ahead and move on to our application problem today. Our application problem says, 24 people line up to use the canoes at the park. 3 people are assigned to each canoe. How many canoes are used? Okay, so let's break that problem down. Alright, so I have my tape diagram over here. So they broke the problem down for us here, and they said question mark times 3 equals 24. Okay, so where did they get the 3? Well, if we look back in the problem, it says 3 people are assigned to each canoe. Oops. Okay, now where did they get the 24? Well, it says 24 people line up to use the canoes. Okay, so then the question mark represents the question that they're asking. How many canoes are used? That's what we're solving for. Okay, and we can already see that the question mark is equal to 8. Okay, but let's set up that problem over here with our tape diagram. Okay, so here at the bottom, the total that they wrote was 24 people. Then on the inside of their tape diagram, they drew a box with 3 in it, which represented the 3 people assigned to each canoe. So then what was left over was, well, how many canoes are actually used? So if we were to solve using our tape diagram, we could have kept adding groups of 3 until we got to 24. So we could have skip count by 3s until we got to 24. And it looks like if we were to do that, we would have figured out that there are 8 boxes of 3. Okay, so there would be 8 canoes. So question mark equals 8. That's what we were trying to solve for. So in a complete sentence, we would say the people use 8 canoes. Okay, so that one I did for you. Okay, so I showed you what we did. On the next one, we're going to work through it together. So make sure you're following along on your whiteboard or your piece of paper. Okay, so all they're saying here is, what if we changed the question mark symbol? Would that affect the problem at all? No, so all they're saying here is, what if we change the question mark to the letter C for canoes? Okay, the problem would still be the exact same, but instead of a question mark, we would use C. So we're going to continue thinking about using letters in our problems when we're trying to find an unknown. Okay, so for example, here's our next problem. 21 students are grouped in 3s to go on a field trip. How many groups of students are there? Okay, so you're going to do this one with me. Let's break it down. So 21 students are grouped in 3s to go on a field trip. How many groups of students are there? Okay, so we're going to break that down. Let's go ahead and draw our tape diagram. Okay, so our total is the biggest number, which is 21. 21 students. So we have 21 students, and we know that they're grouped into 3s. Okay, so here's a box of 3 to represent 3 students in one group. Okay, so what if we were to keep skip counting to get from 3 to 21? Okay, let's go ahead and do that. So we have 6, 9, 12, 15, 18, 21. Okay, so we grouped our 21 students into groups of 3. Okay, so now we need to solve for that unknown. So we were trying to solve how many groups of students there are. Okay, so what letter could we represent for our unknown? What if we did G for groups? So that means we're trying to solve for G groups because we don't know how many groups there are. Okay, so for our multiplication sentence using the unknown, we would write G times 3 equals 21. We don't know what number would replace that G yet. Okay, but if we count in our tape diagram, I see that there's 1, 2, 3, 4, 5, 6, 7 groups of 3. Okay, so that would mean G equals 7. G equals 7. We would just replace the G with the number 7 in the problem. Okay, so let's write our answer in a complete sentence. So the question was, how many groups of students are there? Let's rewrite that question into our answer. So we would write, there are 7 groups of students. All right, very good job with that, friends. So we're gonna go ahead and move on to our problem set, continuing to work with using letters to represent the unknown. Okay, so go back and check Seesaw for video number 2. Very good job following along.